Assalamu alaikum dear students. In previous lecture we discussed the limit of a function at a point. Now today we are going to discuss the algebra of the limits. That is, if we have two functions, say f and g be two functions such that at point x equals to a, limit of x tends to a, f of x is L1, that is limit of f at x equals to a exists. Similarly for g, limit at x equals to a equals to L2. Here it is a. So for both functions, limit at a point exists. Then limit of sum or limit of subtraction equals to the sum of the limits. That is, limit of x tends to a, f of x plus g of x or f of x minus g of x equals to the sum of or the difference of the individual limits. That is, limit x tends to a, f of x plus or minus limit x tends to a, g of x. That is, we can distribute the limits for finite number of functions. That is L1 plus L2 or L1 minus L2. Similarly, product of two functions, if f of x, g of x product, then the limit of the product equals to the product of the limits. That is, limit x tends to a, f of x, g of x is limit x tends to a, f of x into limit x tends to a, g of x, that is L1 into L2. Now whenever limit, this second limit, that is L2, is not equals to 0, then the limit of the rational or the quotient functions is simply limit x tends to a, fx upon gx equals to limit x tends to a, f of x upon limit x tends to a, g of x, that is L1 by L2. Now here this L1 by L2 is defined because this L2 is non-zero. Now if the limit of the second function, that is g function, is 0, then we cannot use here this very property. Similarly, if we have the function which is the scalar multiplication like lambda fx, where lambda is constant, then it's this limit x tends to a, lambda fx equals to constant times limit x tends to a, f of x, that is limit this lambda into L1. So this is the algebra of the limits. Now if we have a constant function, suppose c, that is f of x is c, then we have to prove that the limit of at any point equals to the given function, that is limit of x tends to a, f of x is c if f of x is c. Because here f of x is c means constant function. For each and every point the value of the function is same, that is c. Now if we consider the points which are closer to this a, which are closer to a from left side, then the value of the function at those points is simply c. Hence when we let x tends to c negative, value is c, that is f of x approaches to c. Similarly, when this we consider the points which are closer to the c from right side, that is the point is greater than c, slightly greater than c, the value of the function at those points is simply c. Hence right limit is left limit is simply c. So this means that for constant, limit is the value of that very function. Now if we consider the identity function, that is find the limit of f of x at x equals to 1. This means the identity function. Now we will consider the points which are closer to 0 from this left side, and the points are 0.9, 0.99, 0.999, 0.9999. So this means that the value of the function at these points is same. So these points in the domain points, these points are closer to 1 from left side, which implies that when x tends to 1 negative, the value of the function, that is f of x, tends to 1 from this side, that is 1 is here the left limit. Similarly, if we consider the points which are close to 1 from right side, that is 1.01, 1.001, 1.0001, the value of the function at these points is same, that is 1.01, 1.001, because f of x is x, which implies that when we let x tends to 1 positive, f of x tends to 1 from right side. Hence left limit equals to right limit, which implies that limit of this function is 1. So in general we can say that similarly we can prove that limit of f of x when f of x is x at x equals to a is simply a. Now, if we consider the polynomial is actually the linear combinations of the monomials. Like if we consider polynomial p of x, which is a naught plus a1 x plus so on to a n xn, then prove that its limit at any point is simply replacing variable by that very value. Now, if we consider limit a naught plus a1 x so on to a n xn, we have to prove its limit or find its limit. Then it equals sum of the limits, that is limit x tends to a naught plus limit x tends to a1 x plus so on to limit x tends to a n xn. Now this is constant, which implies that it is simply a naught. Now limit of x tends to a1x is constant, it comes out from the limit, it is simply a1 limit x tends to a x so on to a n limit x tends to xn. Now here xn can be written as x into xn times. So by using the product of limit equals to limit of product equals to the product of the limits. So this means that it is limit x tends to a x limit x tends to a x up to n times, which is simply a into a because limit x tends to a x is simply a. So it is simply a n. Hence from first limit x tends to a, this a naught plus a1 x so on to a n xn, which is p of x actually is the polynomial. It is simply a naught plus a1 a plus so on to a n a raised to power a n. So in this way, limit of the polynomial at a point is simply the value of the polynomial at that point, that is p of a. Inshallah, in tomorrow's video lecture we will discuss the limit of the rational function. So thank you.